All right, so last time in 14.1 we were talking about cylinders, right? And so let's just recap that real quickly. What if you were asked to sketch this cylinder, let's say x equals y squared. Actually, let's make it. Let's do this. Let's do 4 minus y squared. Again, and maybe with this one I'll come off to the side. If you were to sketch that in 2D, right, what's the shape you get? X equals 4 minus y squared. So it's a parabola on its side, right? And it opens to the left because it's negative, right? So it should start over here at x is 4, and then it should open like this. You could keep going. Well, I'll just keep going on this graph. Where would this be then? 2 and negative 2. Is that okay? All right. And so when you want to sketch this in 3D, right, you're going to take that same thing but put it down in the xy plane, right? And so the y values are going to go from 2 to negative 2, right? And then you start out here at 4. And so you get this little parabola thing. It's hard, to draw these, I don't know, to get the right scaling here as things are skewed, right? Because that x-axis is coming out at a weird angle, and depending on how you draw it. But that should be good enough, right? And now z is not showing up, so what do we do with that curve? We take the curve in the xy plane and then
just move it.
Just drag it up, right? And so, again, in my mind, there's 3 interesting points. If you know where those points go, you kind of see everything, right? And so just pull those up the same height, roughly. It doesn't have to be perfect. And then just draw that in on top. If you want, you could draw some, make those vertical. If you can shadow, go ahead and shadow. But if you want to just basically show, I know it's a ribbon of curve. Does that make sense? Okay, so that's what we did last time. And again, it could be when we asked you to sketch curves in this setting, or sketch solid or surfaces, we're always assuming we're in 3-dimensional space. So even if it doesn't say so, you should always assume that's where we are. Okay? So the next ones are going to be more, well, let's just do one. So I think we did this last time anyways, but a recap. In fact, let me just write up a couple of them and have you think about what these might look like. So this is what kind of shape? A sphere, right? So a circle, a ball. And if you drop off one, it's a circle, right? If you drop off any of those. So think about that idea here. If I drop off one of these values, say the z, what is that? X squared plus y squared over 4 equals 1. Not a parabola, close. An ellipse, right? If I drop off that, it's an ellipse, right? And if I drop off this, it's an ellipse. So we call this thing an ellipsoid, but just try to think about what you think that should look like, right? So it's, if you have a ball, if you have a, right, x squared plus y squared plus z squared, they're all behaving sort of the same. You get a circle. Once you put the 4 and the 9 in, then you're stretching in certain directions, right? So you get this oblong shape. So see if you can figure out what those 2 curves look like. And then this one, again, I just want you to reason this out. Actually, we'll do z first. Z equals x squared plus y squared. You might have seen this back in Calc 2 when you had f of xy is this, right? It's the same thing. And then once you draw that, let's just turn it on its side and do y equals x squared plus z squared. So think about those 2 curves, see what you come up with, and then we'll draw them together in a second. So again, these shouldn't take too long. What's this first one again? A sphere of radius 3. So you can draw it however you like. If it's just centered at the origin, I would just draw them like this. I draw my sphere first and I throw my axes in. Doesn't really matter. But do label it, right? So you sketch it and then show the dimensions that you know it to be. So this one, this time I'm not going to draw it first. So you don't necessarily have to draw those in, but I'm putting in the dotted negative parts of the axes. So if y and z are 0, what is x? 1 and -1. So that means I'm gonna go through 1 and -1 like that, right? What if x and z are 0? What's y?
-2 or 2.
-2 or 2, right? If those two are gone, they're both 0. Then you just multiply by the 4, right? And you get plus -2. So the y-intercepts are basically 2 and -2. If you label, that's great. I mean, you should label. And you know, if your scale's off a little bit, that's fine. But just make sure it looks a little bit wider. And then finally, what about the z's? -3 and 3. Oh, put it backwards. And then just try to draw this, ellipsoid the best you can with those. Good enough. Does that make sense? And if you have the axes labeled, those sort of intercepts labeled, then there's no question that you got the right thing. That's why I would suggest, well, I'm not even suggesting. I'm telling you, you have to label it. Okay? To get full credit. And that looks a little more sphery than it should, right? It should be squished here, spread out, and then even spread out more this way. Okay. How about this guy? So z equals x squared plus y squared. So you can do this in a couple different ways. What if there's no x? What's z equals x squared? It's a parabola, right? And so that would look like that, right? What about z equals y squared?
Just like that.
It's a parabola as well, right? So you get a parabola opening here. That. I don't exactly know where those should be. Here. And so you can imagine that you're just going to get a bowl shape like that, right, opening up. That comes. You could think of it, so back when you were first introduced to these back in Calc 2, we talked about level curves. I don't know if you remember doing that, but for instance, if I'm here, if I set z equal to different values, if I set z equal to 4, I have 4 equals x squared plus y squared. So what's that curve? A circle. And so that's basically just saying if you were up here at 4, you get a circle, right? And if you were up at 9, you get, so maybe let's make this 9, and then 4 would be down here, you get a smaller circle. Does that make sense? And so you just basically have circles growing stacked on top of each other, and so you should get that shape. Is that okay? And for right now, our big thing is just be able to sketch some basic ones, be able to recognize them when they show up. So what about this one? What's the difference here?
Just going to the y.
Going in the y direction? Okay, good. So again, parabola on its side here, right? Parabola here. Like that. And then we just get something that looks more or less like that, right? Just somehow indicate that you realize what's going on. And maybe we'll just do 2 more here. Let's see. Let's keep kind of the same setup. What if I had 9 minus squared minus y squared, and then x squared minus y squared. The last one I'll be terrible when I try to draw it, but that's okay. So keep trying to sketch those two. I'm going to write some other ones up here. Don't sketch these yet. I'm going to use them for a different problem. Okay, so let's come back and do these. So what about this first one? Z equals 9 minus x squared minus y squared. Again, if you think of the x being gone, what is that?
From
9 opening down, right?
Yeah.
So it's a parabola opening down, starting up. Let's just say this is 9. And so you're going to get that kind of behavior. And then the x, you should get the same sort of look, right? And so it's basically that same thing we just did over there, only on its side. And with this one, since we're crossing these axes in an obvious place, we should label those. So where are we going to cross there?
3.
3 in both cases, right? That makes sense? We call these paraboloids. They behave like parabolas in both directions, right? Okay, good. And so the big thing we're going to want to do, and I guess you've done it before, is find the volume under this, right? So you realize that's the top, and then you look at the region that it's sitting over as that circle, right? If you remember back in Calc 2, you did volumes, you would have integrated 9 minus x squared minus y squared over the circle. I'm going to switch to polar coordinates. We'll talk about that in a bit. But hopefully that looks a little bit familiar. How about this one? So in the x direction, it's behaving like parabola up, right? And in the y or z, it's parabola down, right? So you got, it opens up like this in this way, and it opens down in the other way. So this one's definitely harder to visualize what's happening. And as I said, I'm going to do a terrible job of doing this. But the idea is that, right, as you move along, you just start dragging these parabolas lower this way. And so you can think of it like that. Right, so you just get a shape that looks more, well, I'm just going to draw it from here over. You get the shape that looks like this. We call these, this is like a saddle curve, right? You get a saddle shape. I got it upside down. But if you looked at this the other way around, it's like a saddle here. Maybe I'll just pull one up on the computer. That'll be easier than me trying to draw it. Again, you don't need to worry about getting a great drawing. Just make sure you're able to see what that should look like. Okay? All right. And so let's pull this up. So I'm going to turn off the lights here. So I'm going to come I'll do a little, actually there's a saddle one here. I'll just use it. Okay, so just pull up. All right, hopefully you'll be able to see these. If you can't see them, I'll zoom into a few at a time. So we'll come grab those bottom two in a minute, but let's just consider these curves right here, okay? Now what we want to do is just match them up to the correct curve on the board here, right? So this is 37 through 44. These all correspond to the 8 different graphs up there. And so take a few minutes, look at these things, right? Think about the things we've just seen, right? This is a cylinder, right? And it's dragged along the x-axis. So the graph, or the function, or the equation that this comes from shouldn't have an x in it, right? It'll just be a function of y and z, and then that's why it gets dragged down the x-axis. This one, right, looks like a paraboloid opening in the x direction, so you should think x is probably a parabola in the y and in the z, right? And so do variants of that kind of reasoning. You got 2 little balls, and so the difference, here, I'll pull them. Is one is stretched further in the x direction, the other stretched further in the y direction, or maybe, yeah, I think that's enough. So think about, which ones of those they should correspond to. And that upper right one is this saddle-shaped one, saddle on its side. So I'll give you a few minutes. Don't shut them out yet. All right. We made any progress? We're still. All right. Shout out one of them. Any of them that you see? What's the? Well, let's do that one I mentioned before. So which one corresponds with 4 here? It shouldn't have an x in it.
39.
39. Right. There's no x. These two both have no x. Right. 39 and 42. And it's this one because you see, right? It's an ellipse that's being dragged along, right? And so this is the equation of an ellipse. And so, which one do we say this? 6. So this one's 6. All right. 2. Did we figure out 2?
42 is 4.
Oh, 42 is 4. So let's see, where's 4? Oh, it's doing it this way. Let's come back to those ones, to 4.
37 is 2.
Actually, I guess maybe as long as you mention that. So here's 4, right? And so 42, again, that one is just some curve in the ZY plane, right? And then it's dragged down the x-axis. So again, it should be the other one without an x, right? And so it corresponds to that. And you can see, right, this is the equation of a hyperbola. And so this makes perfect sense, right? We come up with that one. So let's look at the 2 ellipsoids, so the sphere-ish ones here, 2 and 8. So which equations, so don't necessarily tell me which one exactly, but what do those correspond with? 2 and 8.
7.
8. Okay. 37 and 38. So yeah, so these are both those kinds of equations, right? They just have x squared plus y squared plus z squared equals something with just constants in there. And so how do we tell which one's which?
The first one is 8.
The first one is 8.
Yeah, 7.
Why? So let's think about it this way. If y and z are 0, what's x?
4 and negative 4.
4 and negative 4. If x and z are 0, what's y?
That's
1.
1 and 1.
Plus 1 and 1. So in this case, the x is bigger, right, than the y's. And so which one is it?
2.
That's 2. Does that make sense? And then that leaves this one to be 8, but you can just check again which variable is going to have the bigger intercept. It'll be y in that case, right? So it's stretched in that y direction. Okay, good. So we're making progress. I guess we got both of the bottom ones done, so good. We can move up to here. Any other ones? So maybe we've kind of seen stuff like 3 before, right? And so it should be x. So if you ignore one of the variables, it should be right, x equals z squared or something like that, and then x equals y squared or something like that, because it's opening like a parabola in both directions. And so which one's that? 40, right? So again, don't just kind of ignore the constants, but you have, if there's no z, right, x is 4y squared, and so you get, or 4x is 4y squared, so you get that parabola opening in that direction, and then the same thing here. And so, what did we say it was? 3. And be careful, you know, if they open in different sort of ranges, you have to know which one is which. That should be good. And then how about 41? Which one does that correspond to? 5. It's, again, that saddle shape, right? It opens as a positive parabola in the one direction and a negative one in the other, so up and down. And so this one is 5. Okay, and then that leaves us with 43 and 44 and 1 and 7, right? And so they're both kind of opening like bowls here. The big difference that I would notice is that this one, right, has a piece in the middle here. This one, there's nothing in the middle, right? So how can you decide?
Minus x and x.
Right, so this one's got, well, let's look at this. You're in the middle here, you're at the origin, x, y, and z are all 0, right? And for this one, if you move this way a little bit, there's certain y values where this thing's never defined, right? And so which one of these won't be defined for certain y values?
Negative y.
Why the negative y?
43.
So let's do this.
3 more.
Y equals 0, y equals 0. So in both of these equations, what's that top one become? Negative x squared minus z squared equals 1. Is there any solution to that?
No.
No, right? And so which one is that? That's the one with the hole in the middle of it. Does that make sense? So that's 1. And then by
7.
default, we get 7 here. That make sense? So all we're really looking for in this section is that you can draw some of these basic curves and then be able to recognize this. I hate to take this one example, but I think, you know, come back to this with fresh eyes in a few hours or tomorrow and just try to redo it again. You should be able to sort of get pretty comfortable at matching up certain curves with their functions or equations. Okay, so that should do it for 14.